Hi ladies. All right, so this next lesson is about space geometry. And so if you're following along in your guided notes, a few things that we've already talked about are points, lines, and planes. And we use those basic ideas to define other geometric figures like rays, and two rays can form an angle. We used it to define segments. Several segments can form a polygon. 3 or more segments can form a polygon. But now we're going to step outside that single plane, which again we refer to just like a sheet of paper, and we're going to jump into the solid geometry or space geometry. So space is the set of all points. That's the very generic definition of space. The set of all points. And unlike any one-dimensional lines or two-dimensional planes, space cannot be contained on a flat surface. So some examples of 3D objects are the Toblerone bars. That's a 3-dimensional object. You can see it clearly as a triangular prism. An ice cream cone, 3-dimensional objects. Cubes, dice, anything that you can actually physically touch are 3-dimensional objects. So this lesson is about how to represent 3-dimensional objects in our 2-dimensional drawings. So you might have graph paper, or maybe you have some of this dot paper, and we'll work with using dot paper in class. But to draw a 3-dimensional object in a 2-dimensional surface is called an isometric drawing. So it shows 3 sides of an object in one view. So let's practice drawing some of these 3-dimensional objects, and we're going to start with something that you're probably pretty familiar with already, and that's a box. So step 1 of drawing a box is you're probably given a length, and you're probably given a width, and you're probably given a height. So let's just start by connecting our length, our width, and our height. And those 3 segments that we draw all connect to the same point. Anytime you cannot see, and we can go back and do this after we've completed all the steps, but anything that you can't see through, you're going to represent as a dotted line. So step 2 of drawing the box is, again, to use your dot paper to do the height. So here we used 1, 2, 3 units as our height. So 1, 2, 3 units again as our height. And here, 1, 2, 3 units as our height. So we have 3 segments that represent height. And then we use 2 segments for our length and 4 segments for our width. So now we've got 2 sides of our box. And then we want to do the same thing. 4 segments. Oops, we're going a little off the paper, but 4 segments for our width. And then again, 2 segments for our height. So if we're drawing this out in steps, height, length, width, and after we have that first step, we can draw our height again. I'm just going to use a different color. You can redraw them all if you want to, but then our width, And then the ones that you can't see, I'm going to do in green, will have a hidden height, will have a hidden length, and will have a hidden width. So the ones that you can't see, you should use dotted lines. So some three-dimensional objects that we're going to be working with include the sphere shape, which is a cylinder. The second shape is a prism. So that has the same, so a cylinder has a circle base and a circle top. A prism has some shape base in the same shape, a congruent of that polygon on the top. A sphere is a ball or a three-dimensional circle. Then we have a cone, just like our ice cream cone. It's a base circle, and it all converges to a point on the top. Then a pyramid. And lastly, a hemisphere, which is a circle base. It's a half of a sphere. Okay, so now I'm going to give you a few tips on how to draw these figures. So remember to use dotted lines or dashes for any hidden lines. So step one, we have a circle top, but when you see it, you don't see the full circle. And then we have a circle base. But some of these, like this back part, we can't see. So we're going to represent that with dashes. So once we have our base and our top, and those circles will be congruent, we simply connect the base and the top. For a cone, so again, we start with the circle base, although really we can't see this back part, so we represent with dotted lines here too, dotted lines, since we can't really see that if it was a solid figure. And then the sides all converge to a point at the top. Oops. And then if we are drawing a prism, to start, you start with your cylinder. And then we can do a polygon inscribed within our circle. So that's from lesson 1.7. So some polygon inscribed in your circle, we'll use a pentagon. And then that same polygon will be inscribed in our base. So we do that by connecting our points. So this is in the front. This one here would be not visible. This is visible. Oh, actually, this one probably would be visible. This one is visible. But that last one right in the back is not visible. So we would see our pentagon as our top. And our congruent pentagon as our base. And make sure to use dashes for any pieces that you can't see. And I combined steps 3 and 4. Now drawing a pyramid. Little tip for a pyramid, start with just a circle. or what you would see of a circle. And let's draw some kind of shape. You can use a pyramid. You could have several different shapes. Let's draw a quadrilateral inscribed within our circle. And all of these points converge to a point at the top. And remember to use dashes for hidden lines. So what we would have would be the pieces of our pyramid that we can see. So we've got a quadrilateral as our base. We've got the peak of our pyramid. We can't see the back lines. It's a little bit bigger so we can see it. A great drawing. A little practice of those in class. Not a great drawing, but we can practice. All right, and then a sphere. So with the sphere, we want to have our center of our circle. And once we have that, our circle and our center, we're going to draw another what we would see of a circle. So you don't see the back of that circle, but like a globe, you can see the front here. You can see the whole circle, but what you don't see is the other side of the globe. All right, and then our hemisphere. We're going to draw what we would see of our circle. So it's kind of a flat and stretch out version of our circle. And then we're going to take that and we're going to draw a dome over top of it. But then we need to remember that we don't actually see this little part. So we need to indicate that with dashed lines. So on your own, just thinking about these isometric drawings, how are they different from other drawings that we've done, like drawings of a square or drawings of a triangle? How are these isometric drawings different? And then on your own, try this extra example. When a solid is cut by a plane, the resulting two-dimensional figure is called a cross-section. So this is another vocab term. Cross-section is a two-dimensional figure. But what cross-sections are formed when a sphere is sliced by a plane? What about when a cylinder is sliced by a plane? And then lastly, find an example of each of the solids in this lesson, other than those in the book or models that, well, we haven't talked about any yet, and describe how you would draw them. So these are actual physical solids. So we talked about the ice cream cone or the Toblerone bar. So some examples like that, and bring those to class, or bring ideas of those to class with you. And as always, jot down any notes that you have, and if you have questions, we'll go over them at the beginning of class. Thank you, girls.